Hey Tube, welcome back. Problem number 202, happy number. So basically in this problem, a happy number is a number that eventually reduces to 1 when we repeatedly replacing it with the sum of the squares of its digits. If it enters a cycle, it's not a happy number. So if you look at this example here, so n equals 19, it's a happy number because if we put all the sum of its digits, so 1 in the power of 2 and 9 in the power of 2, it will give 82. And here again, 82 in the power of 2 plus 2 in the power of 2, we give 68. 6 in the power of 2 plus 8 in the power of 2, we give 100. 100 and 100 basically 1 in the power of 2 and 0 in the power of 2 and 0 in the power of 2 will give us 1. So since a cyclic means an infinite loop, we might use a set to store like seen numbers. If a number repeats, we are in a cycle and we stop, we return false. How we will do this? I guess we can do this in 4 steps. So first we will first we will compute the sum of the square of the digits. Number two, we will store visited numbers in the set to detect the loops. Number three, we will know if n becomes 1, we returns true, which is a happy number. Number four, if n repeats, if we have n, we seen this n in the set, we return false, which is unhappy number. We will do this. Yeah, it's a pretty simple, but I guess we need to add a helper function first. I will add a function to calculate the sum of squares of digits. So I will call it sum of squares, and it will take a num as an argument. So we start by let sum and equals 0, and we will return the sum. Here we will, in between, I guess we will make like a while loop. While num is bigger than 0. If num is not bigger than 0, we will stop this loop. So I will create let digit. It would be equals num moduled by n. And the sum will be plus equal the digit multiplied by digit again, because we will have everything will be in power of 2. And num will equals math dot floor num divided by 10. Okay, let me try to check again. Okay, it's some. I guess it looks good, but I guess we need to describe this function more in detail. So the function sum of squares will calculate the sum of squares of the digits of a given number. The steps, it's basically have 3 steps. First, we initialize sum. This variable will store the sum of squares digits. Number 2, we have a while loop. In the while loop, we do 3 things. First, we extract the last digit of num using num moduled by 10, not n. I know there's something not right. After that, we will square the digit and add it to the num, to add it to the sum. Okay. And after that, we remove the last digit from num using math.floor num divided by 10. And after that, we return sum, which contains the final sum of squares. That's it. So this is what the function is doing. So yeah. Next, we will work on the main function here. So I will create let slow equals n. I will have also let fast equals the sum of squares, and I will put in. Okay. Let me also Let me also, what should I do next? What should I do next? I forgot. Yeah, I will create a while loop. The while loop, basically when fast doesn't equal 1 and slow doesn't equal fast. Okay, why we use something called fast and slow? What is reason of using them? So in order to understand how they work, so the function is happy here will determine whether a given number n is happy number using a Floyd cyclic detection algorithm. This is the algorithm that we're using. Cyclic detection algorithm. So a happy number follows this process. It will replace the number with the sum of the squares of its digits. Number two, we repeat the process until the number reaches 1, which is a happy number, or we enters a cyclic not happy number. So and we use 2 pointers here, one called slow and one called fast. Why are we using these 2 pointers? Like if the number is happy, eventually we reach 1. If the number is not happy, it will enter a cyclic like 4, 16, 37, 8, something like that, and it will go again to 4. We have a cyclic thing. We go again to 4. So if we try to think about it here, so we have a slow and fast. The slow will start at n, and fast will start at the sum of squares n, moves ahead by 1 step initially. Here we're doing while fast doesn't equal 1 and slow doesn't equal fast. So basically we loop until fast reaches 1, we indicate a happy number, okay? Or slow meets fast. Basically here we indicate a cycle. So because of that we're using slow and fast. Slow will equals let me say like slow will equals the sum of squares and with slow here, and fast will equals sum of squares, sum of squares, and I put sum of squares and I put fast, and we return here if fast equals 1. Okay, what does this mean? Because I guess it's quite confusing. Oh no, 1 minute, guys. Yeah, this code is better right now. I guess it's easier to see. Yeah, okay. So what this means? So in order to understand the meaning of this, we need to give it like a deeper dive. So slow equals sum of squares. Here, slow moves 1 step. We only move 1 step with slow. Fast equals fast basically moves 2 steps in this one. Okay, I know it's not that easy to understand. So let's just go through this in more details. Um, so here, if you want to think about this part of code, is the key implementation of the Floyd cyclic detection algorithm, also known as the slow fast pointer method, used in the happy number problem. So what happens here? First, we have slow, which moves 1 step at a time by computing sum of squares, and we add slow to it as an argument. And the fast moves 2 step at a time by computing sum of squares and sum of squares in it. Why do we need to use 2 pointers? This done to detect cyclic efficiently without extra space. If the number is happy, n eventually will reach to 1, fast will reach to 1 before slow, and the function will returns true. If the number is not happy, it will enter a cyclic. Using 2 pointers allow us to detect when slow and fast will meet at the same number, which confirms a cyclic. So by this way, we move slow 1 step and fast 2 steps. Let's submit and see if it worked or not. It didn't work. So why? Um, sum of squares is expected identifier sum of squares. Let's submit again. It's still the problem. What did I do wrong? Equals. Yeah, it works. It works now. So let's put like that. Okay, guys. Okay. I'm sorry if I am the code is not visible. I will make sure in the always I solve the problem like that because it will be easier for us to understand, guys. But for now, that's it for this problem, and I hope you like my solution.